Okay, well, happy Tuesday, everybody. So, today I thought we would start off by going over our notes for our line of best fit. So, I'm looking at them right now. So, pull yours out, and really quickly, we're just going to start off right here at the top, being able to derive our line of best fit. And before we do that, we're going to look in to do some review. Specifically, we're going to talk about our correlation coefficient. So I'm going to jump down to my notes here, and we're just going to kind of remind ourselves that our correlation coefficient, that right there, is represented with the variable r. Now, when I'm thinking of this variable r, I'm thinking of a nice long line here, where at one end I've got my -1, and the other end I have my +1. And so we go over here, we have like our perfect negative, we've got our perfect positive, and then right in the middle, this is where we had 0. It's our no correlation. And then over here, we had maybe some strong negative. And right here, we had some weak negative. And that cutoff right there was going to be 0.7. So that's on the negative side, so that one's going to be negative. And then we have the same thing over here on the right. It's just kind of mirrored here. So instead of negative, we have a weak positive. And then right over here, this is where we have our strong positive. And so that's a nice little recap of what our coefficient or correlation coefficient meant right here. So looking at these graphs down here below, so these right here, what we're going to do is just really quickly kind of determine what this correlation coefficient could be. So as I'm looking at this line right here, it looks like right here, that's really close together. And so it's definitely going to be strong. It's going downhill, so it's going to be negative. And then if I'm thinking about what my correlation coefficient is going to be, I know that it's somewhere in between that -1 and that -0.7. Over here on the next one, so number 2, looks like that one's going up, so it looks pretty close to me, so I'm going to say that that one's a strong positive. And then that would mean that my correlation coefficient would be somewhere right in between that 0.7 and 1. So somewhere close to a 1. This next one looks like it's kind of spread out, so it looks like it's going to be weak. And then this one's going downhill, so negative. And that must mean that we have our R value as somewhere in between that -0.7 and 0. And then this last one, it's going up. Looks like it's pretty straight. And so we're going to call that one a strong positive. And just like before, we're going to have that between 0.7 and then 1. And so there we go. That's our nice little recap of what we did last week. Today, we are going to be talking about our line of best fit. Now, yesterday, we did a line of good fit. So we kind of graphed everything by hand. We made some estimations. But this time, we're going to be doing the best fit. And so we're going to have to bring in some technology in order to calculate all of that for us, because that's going to make it really quick. So this example right here says the data set includes the weights of several vehicles and the corresponding highway miles per gallon. So we're going to predict this data will show a positive or negative correlation. And in order to do this, I'm just going to go ahead and I'm going to jump over to my calculator on my phone here. So as we're following along, basically what we're going to do is we're going to click on our calculator, and I'm actually going to use my stat just like we did before. So I'm hitting that stat button right there in the middle. I'm editing my list, and I'm just going to go up to the top here, and I'm going to clear out all the data that I have. Now, once you have all that data out, I'm going to just go ahead and enter in some different values here. So I'm just going to go down this table, and one at a time we're going to kind of check off these different items. And so let's see here, we've got 2200, then enter 4400, enter 3200. We keep on going until I get all of those data points here. So let's see here, 27, 41, 37. Ooh, too many. Let's see here, 2500, 3500, 3200, and 3000. So there's my first list. And then I'm going to bounce over to the right here, and we're going to enter in those corresponding values. So up here at the top, I got 2200, and its miles per gallon is 33. So I got 33, and I'm going to do the same thing. I'm just entering in all of those values: 17, 37, 32, 22, 26, 33, 28, 29, and 30. And so hopefully all of those line up. It looks like we do. We have those nice little lines underneath there. And it looks like we got 12 in each of those columns. So what I'm going to do when it wants me to predict here, let's go ahead and shrink this down. Oh yeah, that's the one. So we're going to predict this. So I'm going back to my calculator. And in order to predict this, let's just really quickly hit that y equals button. And I'm going to clear out some stuff. So my y equals, I don't want that one. I'm going to hit clear. And I'm actually going to turn on my plot up here at the top. One thing that we should kind of double check here is let's just look at the way that this plot is set up. So I'm hitting second, and then that y equals button. It's going to tell me all about these types of plots. Now, we've been doing scatter plots. That's this first one. They have some lines, they have some bars. Looks like we can do some box and whisker plots. Those are super exciting. But we're going to go in this first one. It's a nice step one. I can choose what kind of symbol it has. But the important thing here is that I'm using my L1 and my L2. So that's going to be my X and my Y coordinate. That way, whenever I hit graph, it should give me some values here. And probably what I want to do here is go a zoom and then all the way down here to 9. And it's going to give me a nice little kind of graphic of the different points that I'm looking at. So once again, if I want to do this, I edit my list. Everything's all set up. I go to y equals, make sure that my equations are off. I turn on this plot 1 at the top. That's going to enter in all my points. And then I hit second in that y equals. So second, it uses that plot. And I just make sure that I've got x and y as my L1 and my L2. Now, in order to set that graph, remember, if you have your graph and it looks like this, it's a nice graph, but it's not the one that we want. So I'm going to hit zoom, and then I'm going to scroll down here to the zoom stat one. That's number 9. And so when I select that, that's what gets me that really nice layout of everything. So there we go. Calculator's all done. All I have to do is now look at this, and I ask myself, what kind of trend do I see on this? And it looks to me like this is going downhill. So I am just going to write in here, it looks like it's a negative correlation. So negative. Next, it says predict whether there will be a strong or a weak correlation between the two variables. And so what we're going to do is we're going to look at this and kind of see how those points are grouped together. So looking at those, do those look like they're grouped together, or are they kind of a little bit more spread apart? And to me, they look like they're really close together. And so I'm going to call this one strong as far as my correlation goes. So, did the predict, we did the second prediction, and then in here it says use your calculator to derive a linear equation and its correlation coefficient. And so this is where things get really fun, because yesterday when we were plugging things in and finding our slope, it was also cumbersome, and now we're just going to have the calculator do it all for us. So I'm jumping back to my calculator here. Here's my wonderful little calculator. And in order to find this linear equation, I've got all my data in here. I hit stat, edit, right? All that data is still in here. So I've got all my data entered here. And basically all we're going to do is we're going to hit stat, and it's going to come over to this little calc feature. And we've done this before. We did our different one variable stats, but that's not what we're doing right now. What we're doing is we're going to do our regression. And so we see that right here at number 4. It says lin reg ax plus b. So that's a linear regression. It's going to draw a straight line through our data. And then it has ax plus b. That's kind of like our mx plus b. And so what we want to do is go stat, calc, number 4 here, and I've got a bunch of different options. So here's my function. I am going to choose my x's here. So that's my list 1, just like before. I have my y's, that's my list 2, just like before. And then once again, I've got that frequency list and everything else kind of clear here. So when I hit enter, here I go. Check all this out. I've got my equation, y equals ax plus b. And then it gives me a value here for A, a value here for B, and then it gives me some nice little values here for, it looks like R and R squared. So here's my linear equation. I'm going to my y equals mx plus b, and I have that, let's see here, y equals, but instead of m for my slope, it gives us an a value here, and it looks like this one happens to be quite the number. I'm really glad we didn't calculate this one by hand, because it looks like it's what? 0.00714, and we'll call that good. Then I have my x, and then my b value here is 51, so plus 51. How many decimal places shall we go? Let's just go to 51.17. So there we go. We have found our equation. Look at that. It took us almost no time at all. Now the next part, it says interpret the slope. And so really what we mean is looking just at that a value. Can we kind of add some description to what this means? Now slope, let's just kind of remind ourselves that's our change in y over our change in x. So my y values here, those were those miles per gallon. The x's, those were my weight. And so I'm thinking about what is changing here. It looks like miles per gallon are changing depending on my weight. This is negative, so I know it's going down. And so maybe a way that we could phrase this is that there is a decrease of, what's a good number here? 0.007 miles per gallon And we'll say for every additional pound that our vehicle weighs. So there we go. Heavier your car, less miles per gallon. Okay, the next part, it says evaluate our correlation coefficient. And then in parentheses here, it just kind of reminds us that that is that wonderful R value there. And so looking back at my calculator, I see that R here, and let's just really quickly note this, that R equals negative 0.97. And so if I think about where that lies, all the way up here on my wonderful little timeline that I have up here, 0.9, that's really close to this -1. That's a nice, strong negative right in there. And so that's what I'm going to write. I'm going to write, this is a strong negative correlation. All right. The next part, it says predict the miles per gallon of a vehicle with a weight of 4,350 pounds. So let's go ahead and we'll just kind of plug in some numbers here. Miles per gallon, that's my Y. And so all I need to do is plug in this 4,350 for my X. And so 0.00, we'll just call this 7. I got tired of writing. And then for X, switch over to that red 4,350. And then we'll go back plus that 51.17. Let's see what this one comes to. So I'm going back to my calculator because this is one I don't think I can do it in my head. And let's see here, 0.007 times 4,350, and then plus 51.17, and there we go. We get 20.72 miles per gallon. And then we'll do the same thing for this next one. This time, it looks like we have 1,800 pounds. So going to my equation, negative 0.007. And then I'm using my 1,800 pounds here in order to complete this one. So going back to my calculator here. So negative 0.007 times 1,800 plus 51.17, and it looks like this one, much lighter vehicle here, is that we're going to get a value of 38.57 miles per gallon. And I really wish I got that much gas mileage in my car. That's like 16 or 17, so spendy. All right, so that's that first page. We had a really nice example there, and I've got one more on the back side here. So go ahead and flip your paper over, and actually I would recommend taking a chance or taking a pause right here. Go ahead, try this one on your own, and then we can come back and we can just double check and make sure that we got all the same things here. So go ahead, take a minute, try it on your own, and then we'll come back. All right, so after you have tried this, let's double check your answers here. This one says set of data compares the high temperatures. There we go, high temperatures and the number of customers at a farmer's market. And so we're going to predict whether this data will show a positive or negative correlation. And so just like before, I'm going to jump to my calculator and start entering some of this data. So here I am over at my calculator, I hit stat, hit enter to edit, and this time I am going to go all the way up here. Now I'm concerned that my audio has changed. 1 second here. Hopefully it's still good. Fingers crossed. Here I am. I'm going to enter in all my data. So 68, 63, 74. Ooh, I'm not on the right one. Hold on. There we go. 68, 63, 74. And let's keep on going. 79, 78, 71, 71, and 66. And we'll go over here to the other side, and it looks like we have 317, 355, 463, 419, 507, 482, 433, 388. Almost done. 340. And there we go. Okay, got it entered. I'm going to go and make sure that I can graph this one. So I hit y equals, make sure that my lines are off, making sure that that stat plot is turned on. And then if you haven't already, remember second and then that y equals, I can make sure that I'm using L1 and L2 for my x and my y's. Lastly, in order to make this work before I hit graph, because nothing's going to show up, is that I'm going to hit zoom. So there I go. And then I'm going to go down, and we've been doing some stats. And so right there, I see zoom stat number 9. And now I see all my little dots out there. And it looks like this is, let's see here. First off, we see that it is positive. And then second, this might be pretty strong. At least to me it does. Okay, so the next part is that we're going to use our calculator to derive that equation. And we're going to find that correlation coefficient. So right here, we are going to write our linear equation. So back on my calculator here, I hit stat. I go to calc. I'm going to use that one right there, the lin reg. I think it's number 4 on the list. X is L1, Y is L2, and I'm going to hit enter here. And let's see what we get. My equation looks like I'm going to have a nice y equals. My a this time is 11. Let's just go 2 decimal places. So 6, 3. Then I have my x, and then it looks like my b value this time is a nice big negative number. And there we go. So there's my equation. All done. We're going to look right here at my slope. So that's the 11. Let's just remind our slope. That's our change in y over our change in x. And so it looks like this is going to be how much do our customers change depending on our temperature here. So this one, my slope is positive. And so when I am talking about how to interpret this, we can say it's positive, so it's going up. So there is an increase. And we'll say of, let's see, 11.63. Maybe that's about 12 customers. For rounding, being a little bit optimistic. For every additional 1 degree Fahrenheit. says 1 degree Fahrenheit, not one of. Increase in temperature. There we go. Evaluate our correlation coefficient. So looking at my calculator again, it looks like my R value here is 0.90. And if I think about that, 0.9, really close to 1, so it's definitely right there as a strong, and we're going to have a positive correlation there. Okay, the last two on here is that we're going to predict the number of customers when the temperature is 83 degrees Fahrenheit. So all I have to do, jump to my equation here. And since I'm looking at this when it's 83, we're going to plug in 83 into our function minus that b value there. And then jumping over to our calculator, here I go 11.63 times 83 minus 420.55, and it looks like we get 544.74. There we go. Then it says predict the number of customers when our temperature this time is 55. And so here we go, y equals 11.63, but this time we have a 55 plugged in here. And using our friendly calculator, 11.63 times 55 minus 420.55, and it looks like I get a value of 219.1. There we go. Check it out. Our notes are all done. So thank you for hanging in there and participating in this wonderful little note taking opportunity that we have. Now, if you hang around for just a little bit, I'm going to go through our assignment and do just a couple of examples for that. So what we're looking at here is our assignment. So I have kind of my end, and I'm just going to pull up some of these options. The first one here says correlation coefficient. And so looking at this, all we have to do is look at this and ask ourselves, like, what kind of graph this is. I think we did one of these before. Perfect, positive, submit answer. Hey, look at that. So sometimes we'll have that. Sometimes we might have something that's no correlation, and so we would have to say something like that. And so that's that first one. We've done that. We're good. We're all good at that. The second one, it says strength of linear relationships. And now this one's a little bit different, but really what we're going to do is we've given a lot of information. And when I'm talking about the strongest linear relationship, what I'm really talking about is these R values right down here at the very bottom. So when I think of something that's really strong, I am looking for something that's either close to -1 or +1. And so I see something here, -3.9, or excuse me, -0.39. This one has -0.59, and this one has -0.43. Now this one right here, this one says 1.08, and I didn't realize that that's pretty close to 1, but R cannot be bigger than 1. So I know that it cannot be that one. That one's a bad one. So I'm looking for the other one that's closest, and it looks like this one right here might be the closest. And so I'm going to try that one. Regression 3. Let's see how it works. Check that out. It does. So that's kind of the key there. It looks like there was a nice distractor there. This one, if I do it again, oh, there's another distractor. So be aware of that. The next section, it says create a scatter plot from a data table. Basically, we're just going to look at these. We're given our points, just like yesterday. I go 0, 5, yay. I go 6, 6. I go 1, 5, 9, 2, 3, 4, 5, 5. See here, 7, 6, 8, 2. Man, this is all over the place. And then 3, 3. And so we have to kind of decide what is this going to be. Now, looking at this, if I'm thinking about my association here, what could we say that this looks like? Is it going up? Is it going down? I'm going to be honest, I have not a whole lot of idea here. It looks to me, though, like these two are up here, and perhaps our line might be cutting down through this. So I'm going to say negative. And I'm going to say that these generally decrease. Now, we'll see if this actually fits. Oh, yes. Look at that. See, really flat line. Really hard to tell, but yeah, there was a couple that are kind of dragging it down like this. I feel like we should do one more of those. So let's see here, new one. This one right here, 0, 2. Let's see here, 4, 6, 7, 7, 8, 8, 3, 3. This is a much nicer looking plot than the last one. So this one, a lot easier to see. It looks like this one is positive. And then our y values are going to increase. And so let's see if that works. Oh, yes, perfect. Look at that wonderful green check mark. Sweet. So that's the second section. This one, the next one, this one also super duper fun. I've got a nice set of data here. Looks like this one is positive. Looks like it's a pretty strong positive correlation. Huh. That's fascinating. And so I'm just going to kind of guess that these are my 2 points. And so let's go ahead and we'll hit submit. Oh, yes. Got it. And then lastly, this linear regression here. This is the one that we just learned today. So I'm given a bunch of data. And actually, in Delta Math, there is a handy dandy stats calculator up there. You can always get to it up here as well. So there's a graphing calculator and a stats calculator. And actually, this is kind of a nice one. So I'm given all of these values here, and it wants us to find the projected profit for 2016. And so if I want to find it from these, what I'm going to do is I'm going to first just copy these values to my calculator. Then I'm going to just click that Open Statistics Calculator now that it's open. Now, I've got a few options. I can edit, I can calc, and then I can do a distribution. I am going to edit. I'm going to paste. And then I'm going to go over to a calc. And in this sub-menu here, I want to do that linear regression. Don't want to do a quadratic or cubic or quartic or logarithmic, exponential, power functions, like a sine wave reg. No, we're only doing the line one here. And here we go. So when I calculate this, it gives me those values. So I got my A is 5.2, B is 141.2. And then this thing right here, this diagnostic, this is, if I turn that on, that's where I'm going to get my R and R squared values that we saw on our calculator. So all I have to do is take those values, so 5.2x plus 141.2, and let's see if we can remember this. I got a y equals, what was it, 5.2x plus 142? I don't remember. 41.2, so close. And then we would use this to find my final answer here in an equation. So I'm going to jump to my calculator, and I got 5.2 times, I think that was 2016 that they wanted, plus 141.2. And it looks like I'm getting a value here of 10,624.4. Oh no, what did I do wrong? Fascinating. Did I read this wrong? I probably should have actually read this. Number of years. Oh, since 2008. Gotcha. Not plugging 2016 in. I would have plugged in 8. Bummer. Oh well. We got the right idea. Our equation's right. That's the important thing. All right. Well, hopefully that helps. It's a shorter assignment, and we'll have today and then so tomorrow to work on that as well. So have fun. I'll see you tomorrow.